All right, so let's take a look and just work some partial fraction examples because, that's how you get good at stuff. It's just doing tons and tons and tons of examples, which is an unfortunate thing about, learning and stuff, but still necessary. So what I'd like you to do, and this is, of course, your deal, and you can do whatever you want, but ideally the situation would be that you would attempt to work all these problems on your own and then come check your answers. So I'm going to work all these, but I just thought I'd show them all to you so you could pause the video or whatever and go try them. And then when you get stuck, which will probably happen because, that's how learning works, then you can come see how to actually do them. So something that's important to remember, that if the degree of the polynomial in the top is greater than the degree on the bottom, then you have to do long division first before you do the partial fraction stuff. So that's going to happen here. You're going to have to do long division and here, because if it's greater than or equal to, you have to do long division to simplify it, then you can do partial fractions. So that's something to remember whenever you're working on these two problems, to do long division first, and then do partial fractions on the remainder from the long division. And we can do that too. So pause the video, try to work these out, and we'll take it from there. All right, so here we go. Let's try this guy out. Now, the guy on the degree on the top is smaller than that on the bottom, so we're good to go. We can just go straight from here. Now, what I want to do is I do need to start by factoring the thingy on the bottom. So, I've got this. I can factor out an x, and that's it, I think. It gives me 2x squared plus 3x minus 2. From there, I can do, I think I can foil, negative foil. So that would be a positive 4, and then a minus 1. And that should work? Yes, okay. So, what I'm looking for is that this over, and I'm just going to write it out all factored because it's pretty, this, that is going to be equal to 3 separate factors, 2 and 3. So it's going to be equal to x, 2x minus 1, and x plus 2. And on the top is going to be a, b, and c, because these are all linear on the bottom, so on the top is going to be constant. Now, to make it better, I'm going to multiply the entire equation by x, 2x minus 1, and x plus 2, because I'd like to get rid of the fractions for the purposes of solving for the constants, which means that everything cancels out except on the top. I have that. In the first term, the x cancels out, but everything else is there. In the second term, the 2x minus 1 cancels out, but everything else is still there. In the third term, the x plus 2 cancels out, and everything else is still there. So, yay! This is the algebra your mother warned you about. So, now I'm going to go ahead and start randomly picking x's that is going to make my life easier. So, I'm going to let x equal 0. Because that'll make this one go away and this one go away. So if I let x equal to 0, then my equation becomes 0 plus 0 minus 1 is equal to a times 0 minus 1, and then 0, I'll go ahead and write it out. So 2 times 0 minus 1, and then 0 plus 2 plus b times 0 plus 2. I'm not going to write this out all the time, I'm just doing it for this one. And then c times 0 times 2 times 0 minus 1. Okay, and basically what happens is this is b times 0, so that goes to 0. C times 0, so that goes to 0. Over here on the left I have minus 1 is equal to a times 0 minus 1, and then 0 plus 2. So I've got negative 1 is equal to negative 2a, so a is equal to 1 half. And now I know something. All right, now I just have to do that 3 more times to find the other values. So I can pick, so I picked x equals 0 and I got a. Now if I pick x equals -2, that's going to make the x plus 2 thing go away. So I'm going to pick that. So let x equal -2. And that'll give me, on the left half, -2 squared plus 2 times -2 minus 1. This one is going to go to 0 because the x plus 2, the minus 2 plus 2 goes to 0. The b is going to go to 0. Then the c will be times -2 times 2 times -2 minus 1. So I've got 4 minus 4 minus 1 equals 0 plus 0 plus c times -2 times -4 minus 1 is -5. So I've got whatever that is, -1, there we go, equals 10c. So c is equal to -1/10. And if that doesn't fill you with joy, I don't really know, must be desperately heartless. So, so I got that one. Now I've got one more to do, and that one's going to be a little bit more annoying because it's going to be a bunch of fractions, which, fractions. But I'm going to just suck it up and do it. So to make the 2x minus 1 equal to 0, I'm going to have to guess x is equal to +1/2, right? Because 2 times 1/2 minus 1 would be 1 minus 1 is 0. So that's what's going to make that go away. So the only part that's kind of annoying is here on the left, I've got 1/2 squared plus 2 times 1/2. Well, that's not bad, minus 1. On the right, I've got a times something that's going to go to 0 plus b times 1/2 times 1/2 plus 2. And then c times something that's going to go to 0. Now 1/4 plus 1 minus 1 equals b times 1/2 times, what is that, 4 halves, 5 halves? And then plus 0. Those cancel out. So I've got 1/4 is equal to b times 5/4, which means that b has to be equal to 1/5. So if I multiply both sides times 4/5, the 4's go away, that goes away. And then I have b is equal to 1/5. Now what's amazing about this is now that I know all these, I can go and I can rewrite my original equation, which is this one right here. I'm going to rewrite it off to the side and then pull it over. So basically, well, I'm just going to erase these. So I can come in here and I can say, instead of a, I can say 1/2. Instead of b, I can say 1/5. And instead of c, I can say -1/10. So every time I see this, I can replace it with this. And so I've done some partial fraction decomposition. All right, so that was fun. Let's do another one. Ooh, yay, this is a long division one. So in this case, I have a 4th degree polynomial on the top and a 3rd degree on the bottom. So if I just try to do a straight up thingy here, it's going to get mad and it's not going to work. So I need to do some simplification first. So long division way, there's no x3 plus 4. If you don't know how to do long division polynomials, there's videos for that too. That's going to be divided by, feels like we're in 4th grade again. It's over. X cubed minus x squared minus, ooh, that wasn't good. I didn't write that right. Oops, I think. Oops. X plus 1, like that. Okay, so I left a space there because I don't have an x cubed term. And I can say, well, x cubed goes in x 4th x times. So x times that is x to the 4th minus x cubed minus x squared minus x, wait, plus x. And then I'm going to subtract everything. So the x to the 4th goes away, so I have x cubed minus x squared plus 3x plus 1. Woohoo! X cubed goes into x cubed one time. When I multiply those out, I got x to the 4th minus x squared minus x plus 1. I'm going to subtract all of those and get, wait, I suck at typing. It's supposed to be 3. All right, and so that's going to be 0, 0, 4x. Yeah, 4x and 0. So that means that this is equal to x plus 1 plus a remainder of 4x over x cubed minus x squared minus x plus 1. Okay, so now I can do the actual partial fraction decomposition, but the first thing I had to do was to get it into a good form. All right, so I'm going to go create this off to the side. All right, so next step is going to be to divide out the polynomial. So by divide out, I mean the next step is going to be to factor. Factor, that's the word. Yikes. This has something to do with, let's see, I'm going to pull an x out of the first part. I pull an x squared out of the first part, and I've got that. Well, that looks kind of close. That's x minus 1. If I factor out a negative 1, I've got x minus 1. Okay, so I have x minus 1 and x minus 1, so that's x squared minus 1 times x minus 1. Which actually, oh, that's kind of cool. That actually gets me x minus 1 times x plus 1, and then x minus 1. So that gives me x minus 1 squared times x plus 1. There's probably a better way to do that, but oh well. I'd rather get an answer the long way than no answer at all. Okay, so now basically I want to say is that 4x over this needs to be equal to x minus 1, x, now there's 2 of those, so I have to do it twice, and then x plus 1. These are all linear, so the things in the top are a, b, and c. That was fun. Multiply the whole thing by x plus 1, x minus 1 squared, and I got 4x. This is a lot of work, guys. A x minus 1, x plus 1, plus b, x plus 1, plus c, x minus 1, x minus 1 squared. I feel like I did that right. I hope I did that right. I can go ahead and I can let x equal to 1. So I've got 4 equals something goes to 0 plus 2b plus 0. 2b equals 4. B equals 2. All right, now I can let x equal to negative 1. So that gives me negative 4. Something goes to 0, something that goes to 0, and c times negative 2 squared. So I've got negative 4 is equal to 4c, so c is equal to negative 1. Now, unfortunately, I can't do it an easy way anymore because there's no way to make one of these not go to 0 and make the other ones do go to 0. So I can just randomly pick x is equal to 0, and because it should work for any number you pick. So I'm just going to pick 0 because I like multiplying by 0. So I got 0 on the left. I've got a times negative 1 and a positive 1, b times a positive 1, and then c times a negative 1 squared. So that's 0 is equal to negative a plus b, which I know, which is 2, plus c, which I know. So I've got a is equal to 2 minus 1, so it's equal to 1. Okay, so I have a is equal to 1, b is equal to 2, and c is equal to negative 1. Now it's important to remember that this was all part of a bigger equation that we had up here with the x plus 1 in front. So if we're going to rewrite this whole thing here needs to be rewritten as x plus 1 plus, what was it? It was 1 over x right? What was I doing? Yeah, 1 over x minus 1 plus 2 over x minus 1 squared plus negative 1 over x plus 1. And that's the full partial fraction decomposition of the first one that we had. That was fun. Oh my god, I got 3 more of these to do. I should have thought of this ahead of time. Okay, I got this. This is no big deal. Okay, degree on the top, plus on the bottom, good to go. I can factor that out. I got x squared times, wait, no, can't do that. I got x times x squared plus 4. Yeah, so I've got 2x squared minus x plus 4 over x times x squared plus 4. That equals something x plus something x squared plus 4. Thingy on the top is here is a, thingy on the top here is bx plus c, because it's 1 degree less than the thingy on the bottom. Multiply out. I get messy whenever I'm having fun. 2x squared minus x plus 4 equals a times x squared plus 4 plus bx plus c times a quantity, well, quantity bx plus c times x. Now there's all kinds of fun stuff I can do. What if I let x equals 0? That's a great start. I am such a genius. 0 plus 4 is equal to a times 4 plus 0, meaning that a has to be equal to 1. Bleh. Okay. Now I can let x equal to negative, oh, yeah, no, can't really do that. What if I just plug it in there? I'll just go ahead and set this equal to 1. Let's see, how can I do this in an effective way? I can do 2 equations, 2 unknowns. Oh, let me show you another strategy that might work, that you might like. So let's just go back to the original a little bit. We've got 2x squared minus x plus 4, and that needs to be equal to x squared plus 4, because I already know what a is. I don't need to do extra work, plus bx squared plus cx. I'm just going to simplify the right-hand side to 1 plus b times x squared plus cx plus 4. And now I'm going to pattern match. So I've got a 2x. I know that the coefficient for the x squared has to be 2. So that means that, so I know that 1 plus b has to equal 2. So that means that b has to equal 1. And I know that the coefficient in front of the x has to be negative 1. So that means c is equal to negative 1. So that's another way to do this. So my final answer is that, whatever, that my partial fraction decomposition is equal to a, which is 1 over x, plus b, which is 1x, minus 1 over. So that's what I'm looking at right here is bx plus c. So that's my partial fraction decomposition of that one. So that was a cute little trick. That works. All right, let's do more. More math, please. Oh man, this is division again. I know that I have to divide because in this case, this is a degree 2 polynomial, and this is a degree 2 polynomial. This one is not strictly less than, it is equal to. So we have to do a formal division. I got 4x squared minus 3x plus 2. And that needs to be divided by yes, okay, I'm making sure I got this in the right spot. It's like 4th grade math, except harder. The 4x squared goes into 4x squared one time, minus 4x plus 3. Except I need to subtract everything, minus, plus, minus, 0, x, and minus 1. So really I have 1 remainder, x minus 1 over, well, remainder x minus 1. So I have a remainder, because I'm done. I can't do anymore. So what I have is 1 plus a remainder of x minus 1 over the original x to the up. And that actually looks really pretty. Does that factor? I got a 4 and No, because that's going to make it 12, which is way too high. No, that's not going to give me 12. Well, here's a good way to check. Is the b squared minus 4ac, is that rational? B squared minus 4ac. Oh, that's not good. Minus something big. So that's going to be negative, square root of a negative. So, no, I can't factor that out. The discriminant, whatever. So do you know what I just did? Did I just do something weird? Probably. Whenever I'm looking at the quadratic equation, you know how you have that square root of b squared minus 4ac thing? And if that doesn't come out to a pretty number, then you can't factor it like the way that you would want to. So if I look at the b squared minus 4ac, whatever 16 times 3 is, I guess that's 48. So I'm getting 16 minus 48, which would be negative 32. And since it's a negative and it's also not rational, I know that I can't factor that, so I'm done. And actually, that's it. That is partial fraction decomposition, but not really, because it's really just division of polynomials. That was fun. Woo, at least it was fast. All right. Now this one you might want to go ahead and start by trying to say, oh, the degree on the top is too big or whatever. But it's not, because the degree on the top is 3. Now the degree on the bottom, if you actually multiplied all this out, you'd have an x, and then you'd have an x to the 4th, which would mean that your degree on the bottom is 5. So you're actually okay here when it comes to degrees of the polynomial. So we're good to go. That means we can just go straight into partial fraction decomposition. So because I don't have to write it out again, I'm just going to do this. Plus x squared plus 1, and then I've got 2 of those. Now the degree on the top is linear, then it's, constant, then it's linear, and it's linear again. Beautiful? Doesn't this make you happy on the inside? Makes me happy on the inside. So let's go ahead and multiply this whole thing by x times x squared plus 1 squared. See if you can see that. So means here on the left I've got minus x cubed plus 2x squared minus 3x plus 1. On the right, a times x squared plus 1 squared, bx plus c times x squared plus 1, and then dx plus b times x. Beautiful. Okay, so I can at least get something out of here by letting x equal to 0, and that gives me a 1 on the left equals a times 1 plus 0 plus 0, so a is 1. Okay, that makes things a little bit easier. I really don't want to have to multiply all that out. That just looks like work. So what can I do that would be clever? I don't know if I can do anything clever. I think I just got to work it out. Yark. I hate it when you actually have to, try. So here I'm just going to start factoring or pulling things out. Well, you know what? Hold on. No, I'm sorry. There's just no pretty way to do this. This is just one ugly, sad little problem. This problem did not get enough kisses when it was little. So I'm just going to look at the right, and I'm gonna man up, and I'm going to do this problem. Plus 2x squared plus 1. Alright, now this isn't going to be that bad, if I remember to do it correctly. Alright, now I don't know why I put an A, because A is 1, so I actually don't have to worry about that, since A is 1. So, So, watched anything cool on HBO lately? What do they have on HBO that's cool? I don't know. Game of Thrones, I suppose. The book was better. Cx cubed plus cx plus dx squared plus x. More of a white queen girl myself. So b plus 1 x to the 4th. Where's my x cubed terms? So I've got taking care of my x to the 4th terms. That's cx cubed. I've got which x squared? 2 and d. There's probably a better way to do this. Oh, 2 plus b plus d. Plus b plus d x squared. See? Missed one little thing and it's all over. It's very, very sad. B plus cx. That's why I mark them. Because then I know I've used them. B plus cx plus 1. Alright, the good news is the plus 1s are right. This is supposed to be a plus 1 and it is a plus 1. So that means something good happened in this whole process. But if I equate coefficients, there is no x to the 4th term. So that means that b plus 1 has to be 0. So that means b is negative 1. Alright. If I equate the cubed terms, c has to equal to negative 1 because the coefficient for the x cubed is negative 1. This isn't bad at all. Right, 2 plus b plus d. The x squared coefficient is a 2, so that means that 2, and I know that one, is that. So, d, that's not a d. D has to equal 1. And then e plus c has to be the coefficient for the x, which is negative 3. E plus a negative 1 equals negative 3, so e equals negative 2. Yay. Okay, so that means, hold on a bit. If I have a, so I'm going to take this and move this over here. So what I had was this to make my equivalent thingy, but there was a, yes, that was it. So that means that my final answer is going to be the a, which is 1, and then bx plus c, and then dx plus e. And I know it's so goofy to think, but believe it or not, this is actually going to make your whole life much easier when it comes to integration and Laplace transforms. So now at this point, you should be super, super happy and go have Coke and stuff.